Hello, this is the first video for ACE Math, and this is sequences and series. So a sequence is basically just a list of terms, and a series is you're just adding all the terms. So something like a plus ar squared would be a series, whereas ar squared would be a sequence. So virtually there's no difference between them, and within these are two subtopics we call geometric and arithmetic. Geometric, you're just multiplying together. So in this case, it would be geometric, or 1, 2, 4, 8. This is a geometric sequence, whereas in arithmetic, just adding them. So 1, 2, 3, 4. This is an arithmetic because you're adding 1. This one's a geometric because you're multiplying by 2. So in an arithmetic, we have first term a and common difference d. And basically what this means is your sequence would look something like a plus d, a plus 2d, and on and on. So notice how there's a common difference of d, and that's what we call by the common difference. And if we look at the first term, there's 0 d's. In the second term, there's 1 d. In the third term, there's 2 d's. So we say by the nth term, there is a plus n minus 1 d. But now we say, how do we add them? Because this is for a sequence. What about for series? Well, for series, basically how old people in the past would add them up is just take the first term, take the last term, divide by 2, and then multiply by the number of terms. And this should make fairly obvious sense because we're just finding the average of the entire sequence and then multiply by n, which is the number of terms. So the nth, or sorry, sum of n terms, I'm just going to say sum of n, gives the first term plus the last term, which we said was this, divide by 2 times n. And now if we simplify this, we'll get very familiar, this formula. And those are all of your formulas for arithmetic sequences. There's also other formulas like a1 plus an over 2 times n, but once again, that's just going off of this definition, so I'm not going to go over it. The next are geometrics. For geometrics, we have a first term, a, and a common ratio, r. So our thing should look like this, where in the first term, there's 0 r's, in the second, there's 1 r, in the third, there's 2 r's. So notice how we're multiplying. So we're just going to say the nth term would give a r to the n minus 1. Whereas the sum of n terms, this one's a little bit different because let's say we had a sequence of a plus ar squared plus ar cubed. If we can factor out an a, if we factor out an a, is 1 plus r squared plus r cubed, but we know we can factor this as r to the fourth minus 1 over r minus 1. So basically, how we derive this formula is basically say a times r to the nth minus 1 over r minus 1, which is also equivalent to this. And the reason why a lot of people prefer this form better is because we have something called a sum to infinity. What does this mean? Well, we have to put a slight little boundary on it, and that's that the absolute value of r is less than 1. Because if we say r is 2 or something, then we have 1 plus 2 plus 4 plus ... just go to infinity. So there's no point in trying to calculate it. Or we do 1 minus 2 plus 4 minus 8 plus ... We're going to negative infinity. There's no point in trying to find that. So what we say is the absolute value of r is less than 1, or this. So now we can see, let's say r is 1 over k, where k is an integer. Well then we have 1 minus r to the nth over 1 minus r times a. Now the problem with this is that we can just rewrite this to the nth over 1 minus 1 over k times a. But if we have 1 over an integer to an infinite power, we could say this reaches 0. Because let's say we had something like 1 over 5. We multiply this by itself again, 1 over 25, and 1 over 625, and then 1 over approximately 4,000. And we can keep going, it'll eventually get so small we call it, well sorry, not 0, but 1. sorry, 0. So in this case, it's a times 1 minus 0 over, let's just replace this with 1 over r again. But 1 minus 0 is just 1, so we can just get rid of it and say it's a over 1 minus r, which is a lot friendlier than our other formula. Sorry, a over 1 minus r. But that's it for